Alright guys, welcome to this set of videos. These videos are going to follow along with the notes that come out of your guys' textbook from Chapter 2, Section 5. And what we're going to be doing here in this set of videos is we're going to be taking a look at what we call scatter plots. Now with a scatter plot, what we're going to be doing is we're going to be plotting a data set. And then we're going to look at a number of different things that we can do algebraically given that data set once it's graphed. And also we're going to look at some capabilities that your graphing calculator has when analyzing that data set graphically as well. So we're going to take a look at both of those. Let me give you your objectives or learning targets as we go through this set of videos, things that you should be able to do by the time we get to the end. The first one's going to be use scatter plots and prediction equations. This is going to be us writing our own equation using algebra based on the data that you have graphed. The next one is going to be modeling data using a line of regression, and that is going to be what we're going to do with our calculators. Your calculator will find you a line of regression. When we do it algebraically, what we're going to be doing is finding actually a best fit line. Or a prediction equation, as you will see. Let me go ahead and scroll up for us here and we'll go ahead and get started right away. What you guys already know, scatter plot or dot plot, same thing. And what it's going to be is we're going to be graphing a data set. Most of these are going to be two conditions, either I think we'll look at one that is sales versus the year. We may look at another one that is house prices versus which year it is, stuff like that. All right, so we'll be graphing a data set. And what we're going to see is a couple of different correlations which they show you here. Positive correlation is just going to be the graph appears to be moving in a positive trend. And of course then also a strong, when we say a strong correlation, just means all the data points are closely packed together. They're not right on top of each other. I definitely, when I draw my line, am not going to go through all the data points. That will never happen for any of the problems in this section. You'll never be able to get a line that goes through all the data points. That's okay. But the data points are closely packed together and they're all moving in that general positive direction. The other one would be a negative correlation. Negative correlation is where the data points appear to be moving in a negative trend. And this one also is representing for us a weak correlation. What we see is that the data points are much more spaced out. Like some of them way out here or way over here are kind of out on the fringes a little bit. They're not nice and tightly packed together like they are with a strong correlation. So just keep that in mind as well. And then finally the last one is there's absolutely no correlation. I could draw a line going through there in the positive direction. I could draw a line going through there in the negative direction. It doesn't appear to us that there's any sort of correlation that makes more sense, positive or negative, one over the other. So that takes care of what we're going to be working on here in this section. We'll be doing scatter plots, starting with us doing best fit lines, and then moving to the calculator for lines of regression. Head on over to the next page, and I'll meet you there.